Hello class, I hope everyone had a good weekend and that everyone's doing well when they start watching this video. We're going to be talking about mixed circuits today. So we've learned about parallel, we've learned about series, now we're going to try to put them together and see what happens. So just a quick reminder to get our brains working again. How do we find our total resistance in a series circuit? Well, we just simply add them all together. We have R1 plus R2 plus R3. And we just keep adding until our n number of things. And how do we find our R total in parallel? Well, it's very similar, but we have 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. We've been practicing this last week, and now we're going to try to put them together a little bit. So some objectives. We want to learn how to redraw and simplify some of these mixed circuits so that we can solve them easier. And then practice redrawing them, so we're going to learn about it, practice it, and that's what we're going to work on today. This is a really good video to explain how to do this and just a little bit of the importance of being able to redraw. So please pause my video and go watch that one real quickly. But when you come back, the whole reason we're doing this is that a lot of the time we have complex circuits that can be broken down into series parts and parallel parts. So most circuits are not just simply series or not just simply parallel. It would be awesome if it was, if life was that easy, but things like our computers, things like our phones are much more complicated than that. So we're trying to simplify what is actually here so that we can analyze it and look at it a little bit easier. So it helps us understand them easier. So I'm curious if you guys can be able to find which part is in parallel in these light bulbs. So we have 4 light bulbs. Which 2 of them are in parallel? It's going to be A and B. So we can see A and B are here because when we go from our battery, we can either go left or right. And so that means we have 2 paths or 2 possible loops. So that would be a parallel circuit. So then which 2 light bulbs are in series? Well, C and D would be in series because they're going along the same path. All right, we're going to define a mixed circuit as a circuit that has parallel and series circuit parts. So we can combine them together. Most complicated circuits we find in objects like computers have these kinds of circuits in them. So let's practice. Which part of this is a parallel circuit? So think to you guys self, maybe pause the video. Which part is our parallel part? And then next is going to ask our series part. But our parallel part here is going to be resistors this 3 ohm one and this 5 ohm one. Because they split into 2, that's our parallel part of our series. What is our series part? Well, that is our 8 and our 6 ohm, because if we were to get rid of this middle part, it would just be the one loop, one part. All right, so we're going to practice trying to simplify our diagrams now. So if we had a circuit that looked like this is a series circuit. We have R1, R2, R3, and we're going to go all the way around like that. Our original circuit we can redraw into a simpler circuit by changing each resistor into 1. So instead of having 3 different resistors, we can redraw it by using our equation here. So we want to redraw it so we only have 1 resistor, so it looks a lot simpler. So we know that for a series circuit like this, our total resistance is equal to R1 plus R2 plus R3. So how would it look if we were to combine all 3 of these? Well, it would look like this. We would just combine 1, 2, and 3 into what they have called here REQ. Well, we would call this R total, but it's the same idea. This would be our R total, and instead of having 1, 2, and 3, we just have a total. All right, let's look at another one. Ooh, that picture's a little blurry, but that's all right. We can still see it. We can simplify parts of our circuit to make it easier to calculate our total resistance. So in this one, let's start with our parallel part of our circuit. So the steps we want to do is simplify our parallel part so that it'll look like a series and have just 1 resistor here. Instead of 2, we can simplify it to have 1 for R2 and 3, and then we can add them together easily. So Which resistors are in parallel? Well, it's our R2 and R3, which are measured at, this is 20 ohms and 30 ohms. I know it's a little hard to see. So what is our resistance for R2, 3? Well, we would call the combination, instead of our total, because it's not really our total needs R1 in it, we're going to call it R2, 3. Well, since it's in parallel, we would say that our resistance is equal to 1 over R2, 3, which is equal to 1 over 20 plus 1 over 30. So when we add those together, we would get 5/60ths. Then our next step is to do our fraction flip. We flip what's on the bottom of this fraction with what's over here. Oh wait, sorry, I just divided that first. So I divided this first, now we're going to flip them. Got a little ahead of myself. And then 1 divided by this is equal to 12. So we can see now that this part is equal to 12. Our equation would look, or sorry, our circuit would look like this. And I apologize, it's so blurry, guys. But now instead of having a parallel part here, we're going to have just one resistor that we're going to call they call it REQ. We're going to call it R23. So now we have R1 here and R23 because we have combined them and simplified the redraw. So now we can see we have a series circuit right here, just like this. And we've learned series are a lot easier to add than our parallel friends. So let's try to find our R total now. So we can add our R total by adding R1 plus R23. So that would be 8 up here and 12 down here. And so our total would be 20. So now with our redrawn thing, we found that our total resistance is 20 ohms. We can go all the way back to Ohm's law and use it in our questions where we have R. So if we wanted to find our current, which I think that's what we're going to try to do next, yep. Going back to the basics, we can easily find current using Ohm's law. So if we're trying to find current, we would use I is equal to V over R. We can see this should say 60. I know it's a little hard to see, but 60 volts. And we have 20 for our R total. So using our I is equal V over R, we can say V is equal to 60, R is equal to 20, and divide 60 by 20. Well, that gives us 3 amps or 3 amperes would be our final answer. So going from this very complicated series, which it would be hard to figure out what is our current, and we could simplify it down one step at a time to a series circuit. So we can go from a mixed to a series circuit, from a series circuit to just one resistor, and then we can easily find use our Ohm's law to find our current. So we just want to go slowly in steps here from A to B to C. Let's try another one. This is Mr. Mac's attempt at making an example. It's a little hard to draw on my computer, but it works. So let's do this one together. So we're going to draw the circuit to the right in our notebooks, but first we need to simplify our parallel part. So we're going to say that our parallel part is going to be R1 and R2. So we're going to call this R1, R2, we're going to call this R3. I should have drawn those in there, I'm sorry. So R1, R2, R3. So we need to combine our parallel part by using our parallel formula for resistance. So we want to find the resistance of the parallel part. 1 over R1 we called, and R2 is equal to, 1 over R12 is equal to 1 divided by R1 plus 1 divided by R2. So if we plug in our numbers, we can say that 1 over R12 is equal to 1 divided by 10 plus 1 divided by 5. That gives us 1 divided by R12 is equal to 0.3 ohms. So I plugged this into my calculator and got 0.3 ohms. Then I'm going to do my fraction flip. I flip them, so now I have R12 is equal to 1 divided by 0.3. And that ends up being 3.3 is equal to R12. So I found that our first part is equal to 3.3. So I redrew my picture. So we went from a parallel part. I found that the resistance together here is 3.3 ohms. So I just redrew it, so this looks a lot simpler. Now we have a series circuit. So how can we simplify our series circuit? Well, we know that our total for a series circuit is equal to each resistor added together. So this is resistor 1, 2. This is resistor 3. So if we add those together, we get 3.3 ohms plus 15. And that gives us R is equal to 18.3 ohms, or our total is 18.3 ohms. Now I can redraw it again just to make it even easier for me. So this is the simplest we can make it. We went from 3 resistors, a couple in parallel and then one in series, to just one resistor here. And let's draw our final circuit here, off to the right, sorry. Now given the current, the battery voltage, we could easily use Ohm's law. So if you were given a voltage here, if we were given the current, we can use this resistance to help us find Ohm's law. So that's the idea of our mixed circuits. It's all about simplifying it down so that we can easily find and use our Ohm's law in this case. So I hope that made sense. It's using a lot of information that we've learned last week, so we get to use it again and see it again and maybe help learn the parts that were a little weaker. But if you guys have any questions, as always, please let me know.